Here in this video, we are going to discuss the classification of elementary particles. Elementary particles are subatomic particles not composed by any other. Elementary particles can be put together into two broad kinds, bosons and fermions. So, based on the property of a spin, which is connected by the kind of statistics governed by the particles. Elementary particles which have a spin about the axis and its unit is h cross, which is equal to h by 2 pi. So particles which have a off integral spin, we call it as a fermions. So those which have integral spin, we call it as a bosons. Fermions which obey Pauli's exclusion principle, that means no two identical fermions can occupy the same quantum state. The fermions which obey Fermi-Dirac statistics. The wave function of the fermions is antisymmetric. In the case of bosons, the spin is integral multiple and which doesn't obey Pauli's exclusion principle. So the condition here, there is no condition that it is no number of bosons in any quantum state is not a restricted one. The which obey Bose-Einstein statistics law, and here are the wave function of bosons is symmetric. Fermions are associated with the matter while the bosons are force carriers. The fermions can be further split up into two kinds, leptons and baryons. That based on the mass, it has been split up. Here are the leptons, we call it as a weak particles, and the baryons, it is the massive particles. Here are bosons that can be classified into two types, photons and mesons. Here we will see in detail. Fermions, based on the factor of mass, fermions are further classified into leptons and baryons. Leptons, we call it as a light particles, whereas baryons are much heavy. Leptons are weakly interacting with other particles, but baryons are strongly interacting with other particles. The masses of the fermions are given here. That means the baryons are given here. Lambda naught, lambda, sigma, psi, and omega. Here the masses are listed. Then further, the leptons, when coming to the leptons, it has been classified into three types, electron, muon and tauon. These are the charged particles which undergo weak and gravitational interaction. The electron, it is having a corresponding antiparticle, muon which is having corresponding antiparticle, and tau which is having a corresponding antiparticles. So all these antiparticles also have all the properties of leptons except the charge. The charge alone is just opposite to the lepton particle, but the properties are similar to the leptons. So where the lepton number is 1 for the particles, and for the antiparticles it is -1. So except the leptons, for other particles the lepton number is 0. Coming to the baryons, baryons is also a comes under a fermions. So here it is a off integral spin. Baryons, we usually call it as a massive particles. They are made up of quarks. So they have some internal structure, and these baryons are affected by strong, weak, and electromagnetic interactions. Baryons are further split up into nucleons and hyperons. So these hyperons are much heavier when compared with the nucleons. Nucleons consist of protons and neutrons that are present inside the nucleus, and the charge of the neutron is 0. That is a neutral particle, and the proton, the charge is +1, and the spin of these nucleons is off. The proton is made up of three quarks, two up quarks and one down quark, and a neutron which is made up of two down quarks and one up quark. Hyperons are extremely unstable particles. So the it means the decay time is higher than the operation time. So we call it as a strange particle. When these mesons and baryons, when we combine, We call that particles as hadrons. The next one is the bosons. Boson particles follow Bose-Einstein statistics law. So here there is no conservation law which control the total number of bosons in the universe. Boson is the term which not only include material properties but also includes quanta and photons which arises from the interactions. Bosons are further classified as massless bosons and mesons. So massless bosons are that means it is classified into gravitons and protons. Gravitons means which is having a zero rest mass, spin is 2 and no. Photons is also having a mass 0 and a spin of unity. Here, the particles which have very weak nuclear interactions are mediated by these heavy vector bosons. We call these particles as weak bosons. And the particles which follow strong nuclear interactions are mediated by these massless neutral gluons. So all these particles carries a spin of unity. All these bosons are a quanta of gauge field and we call it as a gauge bosons. Bosons are formed in strong interactions that are of two kinds, two distinct kinds. So these strong interaction are further classified into two kinds, that is pions and kaons. The kaons are much heavier pions. So these are the classification of mesons, pions, kaons, and eta mesons. Pions is having a positive, neutral, and negative element, and a kaons is also having a positive, negative, neutral, and a k naught bar and eta naught. These are